Hello everyone. Today we are going to begin a new chapter, indefinite integration. So what is integration? The first question that should come to our mind is what is integration? So the word integration refers to the process in which we are going to take out the original function from a derivative. Basically, it's the reverse of a derivative. Reverse of a derivative. For example, if fx is given as sin x, then f dash x, which is the derivative of fx, which is the derivative of fx, it will be written as cos x. Therefore, we will say that integration of cos x should give us sin x. This is how we call it the reverse of differentiation or the reverse of derivatives. How do we define this mathematically? Mathematically, we define this as, let us assume there is a function fx such that f dash x is equal to gx. Then we would say that integration, this is the sign of integration of gx into dx. We can also say this is integration of gx with respect to x. This should be equal to fx. Now, whenever we write the equation with respect to integration, we always write a plus c with this. Why do we use a plus c? So let us assume there are two examples, sin x plus 7 in first case, and let us see the second example where we have a function sin x plus 8. So in both the cases, f dash x would be cos x because the derivative of constant is 0. Similarly, here f dash x is equal to cos x. So the derivative of because the derivative of 8 is also 0. Therefore, we can see that regardless of the value of constant present here, we are going to get the same derivative. So when we reverse the process of derivative, we will have to take into account that any constant is possible. So we write down here a general constant c, which is known as constant of integration. It is known as constant of integration. Now, there are a few words which we need to keep in mind here. First of all, gx is the derivative of fx. Derivative of fx. And fx is the original function. We can also call it antiderivative of gx. As gx was the derivative of fx, so fx will be the antiderivative of gx. This also has another name. It is also called by a very common name, which is known as primitive. Primitive. Antiderivative can also be known as primitive. So we will call it primitive of gx. I hope this is clear to you guys now. So how do we find out the derivative or integral of any function? We will use the formula and the knowledge of our derivatives, and we have used them to derive a new set of formulae for the integrals. We will be using those formulas only. So our next topic is integration formulae. Integration formulae for basic functions. So the first formula that we need to talk about is for any function which is 0. So if we write integration of 0 into dx or 0 with respect to x, it would always be a constant because derivative of any constant is 0. Now the next formula would be integration of 1 into dx. Integration of 1 into dx would be x plus c because derivative of x is always 1. Similarly, I am going to note down the other formulae. Integration of x to the power n dx. This can be called as x to the power n plus 1 upon n plus 1 plus c. The reason is whenever you differentiate x to the power n, we reduce a power. We write here n into x to the power n minus 1. So when we are integrating, we are increasing the power. In derivative, the power is then multiplied. In integration, the power is then divided by. As simple as that. Let's talk about the remaining functions and remaining formulae. Let us talk about integration of e to the power x dx. As we all know that the derivative of e to the power x was e to the power x. So the derivative of e to the power x did not change. So the integral of e to the power x will also not change. But this plus c will always be written here. This plus c will have to be written here for every function because of this particular reason. Sin x will also be differentiated and it will give 0. 8 will also give a derivative as 0. So both sin x plus 7 and sin x plus 8 are giving the final derivative as cos x. So we have to put a constant of integration for all integrals. Let us talk about the next example. The next formula that I am going to talk about is integration 1 by x dx. Right now, if you see this formula, x to the power n plus 1 upon n plus 1, you must have noticed that this formula cannot be defined for n equal to minus 1. So we will write here that n equal to minus 1 is not a valid case for this formula. So what happens when n is minus 1? When n is minus 1, we can say that integration of x to the power minus 1x becomes 1 upon x dx. So this has a separate formula. That separate formula is log of mod x to the base e plus c. Now in general, when you are studying calculus, in calculus, if you have a log with base e and there could be any argument, if the base of log is e, we can omit this base because almost every logarithm in calculus will have the base as e. So if we do not write the base, it is assumed that log of b will have a base of e. This is for calculus and calculus only. This will not be true for other subjects, for example in chemistry or physics, but it would be true for calculus. Now let's talk about the next formula. The next formula is integration of sin x dx, integration of cos x dx. So integration of sin x would give minus cos x plus c. The reason is derivative of cos x, d dx of cos x used to give us a minus sin x. So d dx of minus cos x will give us sin x. And we can verify each and every formula in this manner. I'm not going to verify every formula right now. So I will be writing down the rest of the formula without any justification. The integration of cos x is sin x plus c. The integration of sec squared x dx is equal to tan x plus c. The integration of cosec squared x dx is equal to minus cot x plus c. Here's a memory aid. You must have noticed that some of these trigonometric functions have minus sign and some of them have plus sign. So how will you remember these? So please remember this memory aid. Whenever we have c as output, whether it's in cos or in cot, whenever we have c as output, it's always accompanied by minus sign. You can try to remember this if you can, or you can memorize the formulae directly. Let's talk about the next formula. The next formula is integration of sec x into tan x with respect to x. So this would be sec x plus c. The next formula is integration of cosec x into cot x dx. This would be cosec x plus c. And the last formula among the basic formulae would be integration of a to the power x dx is equal to a to the power x upon log a. I am not writing the base, so it means that the base is e plus c. These are our basic formulae. Now let's talk about the next heading. So let's talk about our first category of questions. So we will be talking about methods of integration. The first method of integration uses direct method. So what are direct methods? These are the direct methods which are going to use algebra, which are going to use differentiation, which are going to use trigonometry, geometry and other such chapters, or basic manipulation, or the above formula for integration, and we are going to bring it towards a standard form. So we will transform the question to standard form. Fine. Now what are these standard forms? These are standard forms because we know the formula of evaluating these standard forms. Before I begin these, let us talk about a few properties which we will be using. Properties of integration. These properties will be used for all methods, but they are most important for direct methods. So properties of integration. The first property is integration of fx dx. If it is given that integration of fx dx is equal to gx, then we can also say that integration of f of t dt will be g of t plus c. Whenever we write integration, we must mention a plus c. Now, why is this so? We are simply replacing a variable with another variable. We are replacing x with t, and we can replace this and there is no effect. This is the basic justification for this particular property. The next property is integration of fx plus gx into dx is equal to integration of fx dx plus integration of gx into dx. So we can separate the integrals into two different parts if they are separated by a plus. For example, integration of x plus 1 dx will be integration of x dx plus integration of 1 into dx. Now integration of x dx would be integration x to the power 1 plus 1 upon 1 plus 1, and integration of 1 into dx will be x, and at the last of integration we will write a plus c. Whenever we remove this integral sign, we should remember that we have to write a plus c. So this becomes x square by 2 plus x plus c. This is a simple example of the first property. Let's talk about another small but important property. What happens is sometimes we know the formula of integration of fx with respect to x. We know the formula of this. This is integral of fx with respect to x, and it's given as gx plus c. However, the question that we get is integral of f of ax plus b with respect to x, and we do not know the formula for this. So you should remember the formula for this new equation would be 1 by a times g of ax plus b plus c. This is the formula for the integration of x is replaced by ax plus b, basically any linear form. Now using these properties we are going to solve a variety of questions. Let's proceed to the questions. The first question is integration x to the power 7 dx. So this is of the form x to the power n dx. So we can write x to the power n dx would be x to the power n plus 1 upon n plus 1 plus c. So this should become x to the power 8 upon 8 plus c. Let's proceed to the next question. The next question will be integration of cos 5x plus 7 into dx. So this is similar to the form of integration cos x dx. So the formula for this is integration cos x gives us sin x plus c. So first of all we will write 1 by 5 because we have to write 1 by a. So we are going to write 1 by 5 sine of 5x plus 7, and the last step would have a c. So we solved two questions by this point. Let's proceed with the next one. The next question is integration of cos 7x minus 5 with respect to 7x minus 5. Now this is a little tricky. We have not seen any formula where the variable with respect to which we are integrating is not x but ax plus b. So what we do is we observe that 7x minus 5 are common. So we will say let 7x minus 5 be equal to t. So this becomes integration of cos t dt. So this is the integral of t with respect to t, cos t with respect to t. So this would be sin t plus c. But t was not the variable given in the question. The question had the variable x. So we would have to place the value of t with in terms of x back in the question. So we are placing 7x minus 5 instead of t. So our answer becomes sine of 7x minus 5 plus c. Now let's proceed to another question. Another question would be integration of root under 3x plus 2 dx. This can be written as integration of 3x plus 2 to the power 1 by 2 dx. So this will become 3x plus 2 to the power 3 by 2 upon 3 by 2, and there's the part of 1 by a or 1 by 3, and when the integral sign is done for, we can write a plus c. What is this? We have written x to the power n integration d with respect to x would be x to the power n plus 1 upon n plus 1 plus c. And we also use that integration of f of ax plus b will be equal, if it will be equal to 1 by a times gx, where g of ax plus b. So we are using both of these formulae in tandem. So our result becomes 2 by 9 3x plus 2 to the power 3 by 2 plus c. Let's proceed to the next question. The next question is integration of 1 upon 1 plus 3x plus 4 whole squared dx. Now this is based on a formula that I have not given to you yet. So note down the new formula, write down a note which would say integration of 1 plus x square dx. The value of this integral will be tan inverse x. The value of this integral will always be tan inverse x. Why? That's not important, but always remember that this is a formula that we had not given to you yet, and there are lots of formulae in integration. We will be using those formula which are common in the question. The formula that we do not find in our questions commonly, we will skip those. So our given expression becomes integration of 1 upon 1 plus 3x plus 4 whole square with respect to x. So this is tan inverse of 3x plus 4. However, we must remember that we have to write 1 by a g of ax plus b. So we will have to divide this by 3. And after the integral sign is over, we will write a plus c. So this is our answer. Let's proceed to the next question. The next question would be integration of x to the power 1 by 2 plus 5x to the power 3 by 5 with respect to x. So this becomes integration x to the power 1 by 2 dx plus 5 times x to the power 3 by 5 dx. As 5 is a constant, we simply put it outside of the integral sign. So this becomes x to the power 3 by 2 upon 3 by 2 plus 5x to the power 8 by 5 upon 8 by 5, and as the integral sign is over, we will write a plus c. Now let's proceed. This becomes 2 by 3 x to the power 3 by 2. We had 3 by 2 in the denominator, so we will write the reciprocal, and the reciprocal is 2 by 3. Similarly, we will write 5 into 5 by 8 x to the power 8 by 5. We had 8 by 5 in the denominator, so we multiply it by 5 by 8. So this becomes 2 by 3 x to the power 3 by 2 plus 25 by 8 x to the power 8 by 5. This was the 7th question of the day. Let's proceed to the next question. The next question is number 8. Question number 8 says integration of 3x cubed plus 5 whole squared dx. Now, just remember, we have an expression for ax plus b. We do not have any formula for ax cubed plus b. There is no formula for integrating a function with respect to x cubed. We only have the formula with respect to x. So we will have to change this to a standard form. So how do we do that? First of all, we will expand this entire square. So a plus b whole squared can be written as a squared plus b squared plus 2ab. In case you have forgotten, please remember this. Please remember this formula. So this becomes 9x to the power 6 plus 25 plus 30x cubed with respect to x. So we will be separating the integrals. So we write 9x to the power 6 dx plus 30 integration x to the power 3 dx plus 25 times integration dx. So this becomes 9 into x to the power 7 upon 7 plus 30 into x to the power 4 upon 4 plus 25 into x plus c. So this becomes 9 by 7 x to the power 7 plus, we have a 4, we have a 30. Both of these have a common factor of 2. So we can cancel the 2 with respect to 2. So this becomes 15 upon 2 x to the power 4 plus 25x plus c. We missed the plus c over here. Do not miss the plus c. It would be a wrong answer. Integration will always have plus c. Now let's talk about the next formula, formula number 9. Question number 9. The question says integration of dx with respect to 4x plus 3 whole squared. So this becomes integration of 4x plus 3 to the power minus 2 dx. As you must be knowing, 1 upon a to the power m can be written as a to the power minus m. So this becomes integration of 4x plus 3 to the power minus 2 plus 1 divided by minus 2 plus 1 plus c. Because we have removed the integral sign, we will write a plus c. So the last step will be, we have a minus sign here because of minus 1, and we have 4x plus 3 to the power minus 1 plus c. So this becomes minus 1 upon 4x plus 3 plus c. Now let's talk about the last question for this class. The last question for this class is integration of dx with respect to 3x square plus 16. Now I have given to you a formula that integration of 1 plus 1 upon x 1 upon 1 plus x square with respect to x will be tan inverse x plus c. I had given this formula to you right now. So how do we use this formula in this question? Because the form is similar. This is also a question based on x square. This formula is also based on x square. So what do we do is we write down dx with respect to, let's bring 16 outside. So let's take 16 as common from the denominator. So this becomes 1, this becomes 3x square, this becomes 16. So this can be written as 1 by 16 times integration of dx with respect to 1 plus root 3 upon 4 x whole square. So this is also of the same form. Now we will write down that f of ax plus b when integrated with respect to dx will give 1 by a g of ax plus b. This question does not have a b, but it does have a. So its b is 0. So we will ignore the part which was made out of b. So we will write 1 by 16 into 1 by a. The a here is root 3 by 4 into tan inverse of root 3 by 4x, and the last part is plus c. Now the 4 and 16 get cancelled and this becomes 1 upon 4 root 3 tan inverse root 3x by 4 plus c. So these are the first few questions for this topic. We will meet you in the next class. Till then, thank you. Have a nice day.